are in chapter 4. We finished talking about section 4.1, which was about exponential functions. And we learned that an exponential function has the definition y equals b to the power x, where b is the base, it's a number greater than 0 and different than 1. Okay. And now we will talk about section 4.2, the logarithmic functions. And the logarithmic functions are the inverses of the exponential functions. If you remember, we studied before in 001 the properties of functions and their inverses. We know that if the function is 1-to-1, then it has an inverse. Only 1-to-1 functions have inverses that are functions. As we have seen in section 4.1, the exponential function is 1-to-1. All exponential functions are 1-to-1, so they have an inverse. طبعا if the horizontal line test applies, this is the horizontal line test, and no horizontal line intersects the graph at more than 1 point. If you graph any horizontal line, it will intersect the exponential function in 1 point. So the exponential function is 1-to-1 and it has an inverse. Now, how to find the inverse? We interchange x and y. So we write x in the place of y and write y in the place of x. We interchange x and y, and then we solve for y. Okay. So for example, if y equals to 2x plus 1, this is a function. Let me write it f of x مثلا. If this is a function and I need to define the inverse of this function, so I call it y, and then I interchange x and y. So instead of y, I write it x, and instead of 2x, I write it 2y. And then I solve this equation for y. So I take 1 to the other side, and then I divide by 2. For y is x minus 1 over 2. And then I write it f inverse of x equals x minus 1 over 2. So this is how we define f inverse. We studied this in Math 001. Now, we also studied that if AB is a point on the graph of f, then BA is a point on the graph of f inverse. Yani if the function f takes A to B, then f inverse takes B to A. Okay, so if this is مثلا x and this is y and this is the function f and this is A and this is B, so B is f of A. And then if we define f inverse, then A would be f inverse of B. Okay, so the domain of f is the range of f inverse, and the range of f is the domain of f inverse, because here x is the domain of f and it's also the range of f inverse. Also, we studied that if circle f inverse of x equals x, and f inverse circle f of x is x. This is the composition. If you find the composition of f and f inverse, they cancel each other, and the result is x. And we also have seen that the graph of f inverse is the reflection of the graph of f about the line y equals x. So for example, we have seen that the graph of the exponential function when b is greater than 1 is this function. For now, the line y equals to x is this line. This is the equation of the line y equals to x, then if you reflect this graph اللي هو الجراف of f of x about the line y equals to x, you should have the graph of f inverse. So this would be the graph of f inverse of x. So if this is the graph of f of x, this is the graph of f inverse of x. So these are properties, okay, relations between f and f inverse. It's very important to understand all of them because we will use this now to find the graph or the definition of f inverse. So let us start by the definition of the exponential function. This is the definition, f of x equals b to the power x. So to find the inverse, we do what? We replace f of x by y. So we write it y equals b to the power x, as I did here exactly, okay? Then we interchange x and y. So I write it x equals b to the power y. And now we need to solve this equation for y. But the question, how to solve it for y? How can we bring y down? We don't have any property. We did not study anything like this that enables us to bring y down. So we will need a definition. So we will define a function. We will define y to be logarithm log x to the base b. This is how we read it. Log x to the base b. Okay, so x equals b to the power y, if and only if y equals log x to the base b. So this is the inverse function. So that's the definition. Y equals log x to the base b is equivalent to x equals b to the power y. That's what I said here. X equals b to the power y is equivalent to y equals log x to the base b. Remember, b is a base. So it's a base here in the exponential, and it's a base here in the logarithmic. So b as a base, it must be greater than 0 and different than 1. So b here or here is a greater than 0. It cannot be negative, and it's different than 1. While x here is positive. X is greater than 0. Why x is greater than 0? Because here it is in the range of the exponential function. And if you look here at if you look to this equation as an exponential function, then here in this equation, y is the input or the domain, and x is the range. Okay, x is the range, y is the domain. So you can say here that y could be any real number. Y could be any real number because the domain of the exponential is negative infinity to infinity, while the domain from the range from 0 to infinity. So x should be greater than 0. That's important. So if you have a calculator and try to find log x to the base b, طبعا there is a button here for log xb. If you write b anything, b could be positive number different than 1, مثلا 2. If you take it 2 and write log any number, this number has to be positive. If you write log 0, the calculator will say math error. If you write log -1, the calculator will say math error. So x has to be greater than 0. So the domain of the logarithmic function, that's the domain of the logarithmic function because it's written here. So the domain of the logarithmic function is equal to the range of the exponential function is equal to or is from 0 to infinity. So this function is called the logarithmic function with base b. So that's the definition. Now these two equations are equivalent. This is called the exponential form. This is called the logarithmic form. Okay, these are equivalent. This is the logarithmic and this is the exponential form. if you want, you have to understand how to go from here to here and from here to here. Okay, فput in your mind إنه ال b is always the base. It is the base here and the base here. And y, which is the exponent of b, here it is the exponent, and you bring it out. So you take y out, okay? You bring it alone in the left-hand side. So you write it y equals log x to the base b. This is how we change from exponential to logarithmic. Let us try to مثلا, let me give you some examples. Let me give you some examples. يعني مثلا, for example, we know that 2 to the power 3 equals 8. Okay, this is exponential form. Change it to logarithmic form. How to change it to logarithmic form? The 3 comes here alone, so 3 is equal to log, and the base is 2, so you write it here as a base, and you write 8 here. So log 8 to the base 2 is 3. You can check this by calculator. Okay, for example, another one, مثلا 1 over 4 to the power negative 1 equals 4. This is correct. Okay, this is a true equation. 1 over 4 to the power negative 1 is 4. How to write it? In the logarithmic form, negative 1, which is the power, I take it here, بعدين I write log, بعدين البيز is 1 over 4, you write it here, and you write 4 here. So log 4 to the base 1 over 4 is negative 1. Also, if you have the log, مثلا log 1 to the base 7 is 0. This is a fact. You can check it by the calculator. Now, how to write this in the exponential form? Okay, how to go from the logarithmic to the exponential? b is the base. You write it first, b, and then you raise it to the power y, which is in the right-hand side, and then you say equals x. So here, 7, which is the base, to the power 0, which is the number in the other side, equals 1. And of course, this is correct. 7 to the power 0 is 1. So this is the exponential. This is the logarithmic. This is the exponential. So this is how we move from exponential to logarithmic and vice versa. Here are some examples. Here, how to change. This is the first objective. The first objective, and how to change from logarithmic to exponential. So I'll give you logarithmic and you change it to exponential. So how to do it? Like this. See, look here. b to the power y equals x. b to the power y equals x. So this would be 5 to the power 2 equals x. So this is the first one. And this one, b to the power 3 equals 64, like this one. And this one, 3 to the power y equals 7. So this is how we change from logarithmic to exponential, and how we answer this question. Write each equation in its equivalent exponential form. Okay. يلا مثلا write this equation in its equivalent exponential form. يلا, this is logarithmic, change it to exponential. يلا, who can answer? b to the power 2 equals 25. أحسنت. Another question. Write this in its equivalent exponential form. This is logarithmic. So 6 to the power y equals 216. Okay. The second objective, how to change from exponential to logarithmic. Okay. From exponential to logarithmic. So I'll give you exponential like this, and you need to change it to logarithmic. We said what? We take the base, we put the base immediately 2 equals. Okay. So it would be 2 equals log the base is to the power of, when you take the power immediately 2 equals log the base, which is 12, and then you write x here. So 2 equals log x to the base 12. Okay, here 3 equals log 8 to the base b. Okay, here y equals log 9 to the base e. Okay, this is how we change from logarithmic to exponential. So for example here, the answer of this one would be 5 equals log x to the base 2. هنا 3 equals log 27 to the base b. هنا y equals log 33 to the base e. هنا write this equation in its equivalent logarithmic form. This is exponential. Change it to logarithmic. ها يلا 5 equals log what x to the base 2. هنا مثلا y equals log 200 to the base 7. So this is how we change from logarithmic to exponential, and you can solve these exercises. I leave it for you. Write each equation in its equivalent exponential. Change number 5, 11, 15, change 5 to exponential. وهنا 11 change exponential to logarithmic. 5, 15, 19 the same, change to logarithmic. 15, 19, all of this, change them to logarithmic. Okay, objective 3, maybe this one would be the last objective today. Okay, evaluate logarithms. We studied in 4.1 how to evaluate exponential function, and now evaluate logarithms. How to evaluate? Evaluate means find the value of. Okay, so how to evaluate log 16 to the base 2 without a calculator. Now, if you remember carefully, the relation between, we said that y equals log, this is very important to memorize, b, f and only f, x equals b to the power y. Now, how do you understand this? If you want to find y, okay, we need to find log x to the base b, yani y, yani here, log 16 to the base 2. What is log 16 to the base 2? Yani what is y? If you want to find y, think like this. What is the number that b to this number would be equal to x? Okay, so here, for example, log 16 to the base 2. Think like this. 2 to what number equals 16? Okay, 2 to what power gives 16? That will give you the answer of log 16 to the base 2. 2 to what power equals 16? 2 to the power 4 equals 16. So log 16 to the base 2 is 4. So you can answer log 16 to the base 2 without a calculator by thinking 2 to what power equals 16 will give you the answer. Here, for example, 7 to what power equals 1 over 49. In fact, 7 to the power negative 2 will give you 1 over 49. So log 1 over 49 to the base 7 is negative 2. مثلا log 5, 25. 25 to what power equals 5? Actually, 25 to the power half. Yani the square root of 25 is 5. So log 5 to the base 25 is half. Here, 2 to what power equals 2 to the power 1 over 5. طبعا 1 over 5 لأنه 2 to the power 1 over 5 is just square fifth root of 2. We mentioned if you need the nth root of a, you can write it as a power as a to the power 1 over n. Also, the nth root of a to the power n, you can write it, and usually they write n here and m here. It doesn't really matter. If you write m here and n here, then it is a to the power m over n. Okay, so for example, evaluate this. So you have to think 5 to what power equals 1 over 125. 125. طبعا if you have a calculator, you know that 5 square, 5, 3 in fact, 5 to the power 3 is 5 times 5 times 5, and this is 125. If you raise 5 to the power 3, you have 125. So 5 to the power negative 3 would be 1 over 125. So this would be negative 3. For example, here, what is log 1 over 5 to the base 5? So you ask yourself, 5 to which power equals 1 over 5? And if you really
-1.
understand, yeah, -1, you will know that 5 to the power -1 is 1 over 5. So log 1 over 5 to the base 5 is just -1. Here, you think 36 to what power
Half.
equals 6. طيب to the power half لأنه square root of 36 أو 36 to the power half is 6. إذن الأنسر is 6. Okay. Sorry, الأنسر is half because 36 to the power half is 6. So log 6 to the base 36 is half. هنا 4
2.
to what power? Yeah, equals 16 to the power 2. So that's the answer. I think we have some time, maybe another 3 minutes to take the basic logarithmic properties. This is objective 4. Well, we have log BB1. Log BB1. Why? Because b to the power 1 is b. So log 7 is 1 because 7 to the power 1 is 7. Log 2 is 1. Log b is 1. Okay, because b 7 to the power 1 is 7. B to the power 1 is b. Also, log 1 to any base is always 0 because b to the power 0 is 1. So log 1 to the base e is 0. Log 10 to the base, log 1, it has to be log 1. Log 1 to the base whatever مثلا 100 is 0. Log 1 to any base is 0. Log BB is 1. So here log 7 is 1. Log 1 5 is 0. Here log 9 is 1. Log 1 8 is 0. Okay. Also, we have the last property that comes from the inverse. We said that if circle F inverse of x is x, and F inverse circle F of x is x. So now we have this important point, and no, if F of x is the exponential, then this is the inverse function. يعني f of x equals b to the power x. الانverse here f inverse of x log x to the base b. Examples. What is the inverse of 2 to the power x? F inverse of x is log x to the base 2. This is the inverse function. b to the power x الانverse here log x to the base b. For example, مثلا g of x 1 over 3 to the power x. What is the inverse function? Well, g inverse is log x to the base 1 over 3. Okay, this is the inverse function. Now, if you find f circle f inverse, what would be f here? What would be f circle f inverse of x? It would be f of log x to the base 2. This is the definition of the circle. It would be what? It would be 2 to the power log x to the base 2. It must be x. Here also, here, if you find g inverse circle g of x, it would be g inverse of 1 over 3 to the power x. It would be log, and you replace x by 1 over 3 to the base x, وهنا الباور 1 البيز 1 over 3. فالانسر should be x لأنه f circle f inverse is x و g circle g inverse is x. So we will have these properties. Log bx to the base b is x, و b log x to the base b is x. So here log 4 to the power 5 to the base b is just 5 these cancels each other. Exponential والlogarithmic cancels each other, and the answer is just immediately 5. Here, 6, 6, they cancel each other, and the answer is immediately 9. So the answer here is 8. The answer here is 17 because they cancel each other. The answer here is 8. The answer here, log 1 is 0. Always log 1 is 0. So I stop here. We finished 4 objectives of 4.2, and inshallah tomorrow we continue section 4.2. Please